You were born with 100 trillion neural connections, but you only became you by losing half of them. Welcome back. It's good to have you here. Today, I want to ask you a question that sounds simple, deceptively simple, but if you really sit with it, it might just cause the ground beneath your feet to feel a little less solid. The question is, who are you? I don't mean your name. I don't mean your job title, or where you're from, or who your parents are. I mean, what is the stuff of you? If we strip away the external labels, we are left with a biological reality. You are, fundamentally, a vessel carried by a 3-pound lump of strange, pink, jelly-like computational material sitting silently inside the dark vault of your skull. That is the brain. And the story of the brain, as we're going to explore today based on the incredible work of David Eagleman, is not just a biology lesson. It is the story of reality itself. It is the story of how you act, how you decide, and how you perceive a world that might not actually exist the way you think it does. We tend to think of ourselves as fixed entities. You wake up, you look in the mirror, and you say, "That's me." But the central thesis we're going to dive into today suggests something far more unsettling and far more beautiful. Identity is not a fixed point. It is a moving target. You are a different person today than you were yesterday, and you will be someone else tomorrow. Because the physical architecture of your brain is constantly being rewritten by the very life you are leading. Let's start at the beginning. And I mean the very beginning. Let's talk about being born. Have you ever watched a nature documentary? You see a baby zebra drop out of its mother, hit the savanna ground with a thud, and within, what? 45 minutes, it's standing up. It's staggering. An hour later, it's running with the herd. It knows to fear lions. It knows to follow its mother. It is, in a sense, pre-programmed. It arrives in the world with a brain that is hardwired. Now, compare that to a human infant. If you've ever held a newborn, you know the truth, they are useless. And I say that with love, but biologically, they are helpless. They can't lift their heads. They can't focus their eyes. They certainly can't run from a predator. If you drop a human baby on the savannah, it's game over. So, here is the evolutionary puzzle. Why would nature, which is usually so ruthless about survival, create a creature that is so incredibly vulnerable for so long? Eagleman introduces us to this concept of being live-wired versus hardwired. The zebra is hardwired. Its brain is fully formed at birth. It has the software pre-installed. But there is a trade-off. That zebra is a prisoner of its niche. It can survive on the savannah, sure, but put a zebra in the Arctic, or in the middle of Manhattan, and it doesn't know what to do. It cannot adapt. Humans, on the other hand, are born unfinished. We are born live-wired. This helplessness is actually our greatest strategic advantage. By arriving with a brain that isn't fully connected, we are allowing the world to shape us. We aren't built for one specific environment. We are built to adapt to any environment. This is why humans can live in the frozen tundra, the Sahara Desert, the rainforest, or on a space station. We are the ultimate shapeshifters because our brains are designed to be molded by the specific culture, geography, and family we fall into. We trade immediate survival skills for infinite flexibility. But how does this molding happen? This is where we get into the architecture of the brain, and it's not what you might expect. There is a common misconception that growing up and getting smarter is about growing more brain cells. We think, oh, the brain gets bigger, so there must be more stuff in there. But the reality is actually a process of refined subtraction. It's a process of pruning. Think of it like this. Imagine a block of marble. A sculptor doesn't add more marble to create a statue of David. He chips away the stone that isn't David. He reveals the form by removing the excess. That is exactly what your brain does. When a baby is born, its neurons are mostly disconnected. But in the first 2 years of life, there is what scientists call a synaptic explosion. The brain is frantic. It is forming connections, synapses, at a rate of 2 million per second. 2 million per second! By the time a child is 2 years old, they have over 100 trillion synapses. That is double the amount that you, as an adult, have right now. So, a 2-year-old has more connections than you do. But then, the sculptor gets to work. The brain begins to look at the environment and asks, which of these connections do I actually need? This is the use it or lose it principle. If a neural pathway is used, say, the pathway for hearing the specific sounds of your mother tongue, it gets reinforced. It gets stronger. But the pathways that aren't used? They wither away. They are pruned. By the time you reach adulthood, 50% of those childhood connections are gone. Let's look at language to really understand this. This is fascinating. A 6-month-old baby, regardless of where they are born, can hear the difference between every sound in every language on earth. They are universal listeners. But take a child raised in a Japanese-speaking household. The Japanese language doesn't distinguish between the R sound and the L sound. It's not relevant to their environment. So, because that specific neural pathway isn't being used, the brain prunes it. It treats it as excess marble. By the time that child is an adult, they physically cannot hear the difference between rake and lake. It's not that they are being stubborn. Their brain has physically deleted the hardware required to hear it. So, in a very literal sense, your environment sculpts who you are by taking away the parts of you that you don't use. You become you through a process of elimination. Now, this strategy of live wiring, of waiting for the world to finish building the brain, is a gamble. It assumes that there will be a world there to do the work. It assumes there will be love, language, touch, and interaction. But what happens when that gamble fails? What happens when the world doesn't show up? We have to talk about the tragedy of the Romanian orphanages. This is a dark chapter in history, but it teaches us something vital about our biology. Under the regime of Ceausescu, there was a ban on contraception and abortion, leading to hundreds of thousands of unwanted children ending up in state-run institutions. These places were horrific. The children were fed and washed, but they were almost never held. They were left in cribs, staring at white ceilings, with zero social interaction and zero sensory stimulation. Researchers, specifically Dr. Charles Nelson, later studied these children. What they found was heartbreaking. Without that social input, the live wiring process stalled. Their brains didn't receive the electrical surges needed to build healthy circuits. EEG scans showed barely any activity. These children developed indiscriminate friendliness. They would latch on to any stranger, desperate for connection, but they also suffered from significantly lower IQs and severe developmental issues. The study revealed a critical window. If a child was removed from that environment and placed in a loving home before the age of 2, they could recover. The brain could rewrite itself. But after age 2, the scars became permanent. The marble had hardened. It proves that we are not self-made. We are socially made. Our biology requires other human beings to function. So, we survive childhood. We get pruned. We develop an identity. And then, we hit that turbulent, chaotic storm we call adolescence. Why are teenagers so difficult? Why do they take stupid risks? Why are they so emotional? For a long time, we just thought it was hormones. But Eagleman argues that the teenage years are actually a second massive wave of brain reorganization. It's a construction site. There are 2 major things happening in the teenage brain, and they are happening at different speeds. This is the crucial mismatch. First, you have the emotional and reward-seeking centers of the brain, specifically an area called the nucleus accumbens. In a teenager, this area is fully lit up. It is screaming for excitement, for social approval, for dopamine. It is as active as it is in an adult, maybe even more so. But then, you have the prefrontal cortex. This is the CEO of the brain. It handles impulse control, planning, and understanding consequences. The problem is, the prefrontal cortex doesn't finish maturing until you are about 25 years old. So, think of a teenager like a high-performance sports car. They have a Ferrari engine, that high-octane drive for reward and social status, but they have the brakes of a bicycle. They physically lack the neural hardware to stop themselves from doing something dangerous if the social reward feels high enough. There was a study, the shop window experiment. They put adults in a shop window and had people stare at them. The adults felt a little awkward, maybe a bit stressed. But when they put teenagers in that window, their emotional brains went nuclear. They were shaking. The social pressure felt like a life-or-death situation. That is the medial prefrontal cortex peaking in activity. It explains why, when you were 15, an awkward moment in the cafeteria felt like the end of the world. Because to your brain, it was. So, we pass through the storm of adolescence. We reach our mid-20s. The tectonic shifts of the brain settle down. But does the story end there? Are we finished products? Absolutely not. This is where we get into plasticity in adulthood. The brain never stops changing. The most famous example of this is the London taxi drivers. To drive a black cab in London, you have to pass a test called the knowledge. You have to memorize 25,000 streets and 20,000 landmarks. It takes years of study. Scientists scanned the brains of these drivers and found something incredible. The posterior hippocampus, the part of the brain responsible for spatial memory, was physically larger in these taxi drivers than in the average person. Think about what that means. They didn't just learn a map. The act of learning physically grew their brain, like a muscle. It proves that even in adulthood, the brain is a shapeshifter. It rewires itself based on what you do every day. But what happens when the wiring breaks? What happens when we lose the ability to record our lives? This brings us to the story of Henry Molaison, known in medical literature as patient HM. Henry suffered from severe epilepsy. In a desperate attempt to cure him, surgeons removed his hippocampus. The good news? The seizures stopped. The bad news? Henry could never form a new memory again. He lived the rest of his life in the permanent now. You could meet him, leave the room, come back 5 minutes later, and he would introduce himself to you all over again. But here is the profound insight from Henry's tragedy. Researchers asked him to imagine the future. They said, "Henry, imagine you are going to the beach tomorrow. What do you see?" And Henry couldn't do it. He said, "It's just emptiness. Like waking up from a dream." This changed everything we thought we knew about memory. We used to think memory was about recording the past, like a video archive. But Eagleman argues that the evolutionary purpose of memory is actually to simulate the future. We use the fragments of our past, the face of a friend, the feeling of sand, the sound of waves, to construct hypothetical scenarios so we can predict what will happen next. Without memory, you have no future. You are stuck in a void. So, if our identity is tied to this ability to remember and predict what happens when we age, we all fear dementia. We all fear the brain decaying. But there is hope, and it comes from a group of nuns. The nun study is one of the most fascinating pieces of research in neuroscience. Researchers tracked over 1,000 nuns and clergy members because they lived very similar, controlled lives. They donated their brains to science after they died. When the pathologists looked at the brains of some of these nuns, they were shocked. They found brains that were riddled with Alzheimer's disease. Physically, the brains were devastated, plaques, tangles, the works. These women should have been completely incoherent in their final years. But here's the kicker: when they were alive, they showed zero symptoms. No memory loss. No confusion. They were sharp as a tack until the day they died. How is that possible? How can you have a diseased brain but a healthy mind? The answer is cognitive reserve. These nuns spent their lives constantly learning. They did puzzles, they debated, they taught, they engaged in complex social interactions. By doing this, they built a brain with redundancy. Eagleman uses the toolbox analogy. Imagine your brain needs to open a bolt. The standard tool, the wrench, is the normal neural pathway. Now, Alzheimer's comes along and breaks the wrench. For most people, that's it. They can't open the bolt. Dementia sets in. But the nuns? Because they had challenged their brains their whole lives, they had a toolbox full of other tools. The wrench is broken? Fine. They reach for the pliers. They had built alternative neural pathways to achieve the same result. It tells us that while we might not be able to stop the physical aging of the brain, we can build a buffer. We can protect our self by staying curious. Now, I want to pivot to something even deeper. We've talked about how the brain grows, how it ages, and how it remembers. But how does it perceive? This is where things get a little Matrix Y. So stay with me. We assume that we see the world as it is. I look at a red apple and I think, that apple is red. But Eagleman reminds us of a fundamental truth. The brain is locked in a dark, silent vault. It has no windows. It has no ears. It floats in fluid inside your skull, in total darkness. The only thing the brain has access to are electrochemical signals. Spikes of data coming in from the eyes, the ears, the skin. These signals are just electricity. They are not red or loud or soft. The brain has to take this raw, generic electricity and translate it into a reality. Think about the stadium analogy. Imagine a stadium full of people. When you are awake and conscious, the neurons in your brain are like that crowd having thousands of individual, complex conversations. It's chaotic, but it's rich. That complexity is you. But when you fall into a deep sleep, the crowd starts doing the wave. Everyone stands up and sits down in unison. The complexity vanishes. The rhythm takes over. And your consciousness, disappears. So, consciousness is a rhythm. But reality? Reality is a construct. We don't just see with our eyes. We learn to see. We have to practice seeing. Take the case of Mike May. He was blind for 40 years. Then, through a stem cell miracle, he regained his sight. He opened his eyes, and the photons flooded in. But he didn't see faces or cars or trees. He saw a mess of colors and shapes. He couldn't tell if a hallway was a flat painting or a 3D space. He couldn't recognize his own kids by looking at them. Why? Because for 40 years, his brain hadn't been practicing. It hadn't been cross-referencing visual data with movement. This leads us to the famous kitten experiment from the 1960s. 2 kittens in a drum with vertical stripes. Kitten A is allowed to walk around. Kitten B is in a basket, suspended, watching the same stripes, but not moving its own legs. Kitten A grew up with normal vision. Kitten B was functionally blind. Why? Because the brain needs to understand that when I move my head this way, the world shifts that way. We don't just see with our eyes, we see with our bodies. Perception is an active engagement with the world. And this brings us to the final, and perhaps most mind-bending, concept of today's deep dive, the internal model. We think our eyes act like cameras, streaming a live feed of the world into our brains. But that's not efficient. The world is too fast, and the brain is too slow. It takes time for visual signals to travel from the retina to the cortex. If we relied solely on that feed, we'd be living in the past, about half a second behind reality. We couldn't catch a baseball. We couldn't drive a car. So, the brain cheats. It guesses. Eagleman describes the brain as a reality generator. It has an internal model of the world, a map built from all your past experiences, and it projects that map onto the world. Anatomically, this is proven by the connections between the thalamus, the relay station, and the visual cortex. There are 10 times more connections going backward, from the brain to the eyes, than there are coming from the eyes to the brain. Think about that. Your brain is shouting its expectations at your eyes 10 times louder than your eyes are whispering the reality to your brain. The brain is constantly predicting what it will see. I expect to see a door here. I expect the floor to be solid. It only pays attention to the eyes when there is an error, when something unexpected happens. This is why, if you are put in solitary confinement, like the story of Cold Blue Luke in the book, you start to hallucinate. Luke was in the hole, in total darkness. But he saw lights. He saw himself flying. Why? Because his brain's internal model was still running. It was still generating predictions, but there was no sensory data from the outside world to rein it in. The internal reality took over. We see this in the hollow mask illusion. If you look at the inside of a mask, the concave side, your brain will almost always force you to see it as a face sticking out. Why? Because in your entire life, you have never seen a face that curves inward. Your internal model says, faces stick out. And that expectation is so powerful that it overrides the actual light hitting your eyes. You see what you expect to see, not what is there. So, where does this leave us? We started by asking, who are you? We've learned that you are not a fixed object. You are a live-wired creature born incomplete so that you can adapt to anything. You are a sculpture, carved by the pruning of the connections you don't use. You are a biological machine that requires love and social contact to function. You are a turbulent mix of impulse and control during adolescence. You are a plastic, shifting network that can physically grow by learning new streets or solving puzzles. And perhaps most profoundly, you are the creator of your own reality. You live inside a simulation constructed by your memory and your expectations. The colors you see, the sounds you hear, they are a translation, a story told by your brain to help you navigate the dark vault of existence. Identity is a moving target. It is a story that is being rewritten every single moment of every single day. And that, I think, is the most empowering takeaway from Eagleman's work. You are not stuck. You are not hardwired. You are a work in progress. And as long as you are learning, as long as you are experiencing, as long as you are connecting with others, you are continuing to write the story of you. Thanks for listening.